Okay, I think we are ready. Good afternoon. My name is Juliana Duarte. I'm an assistant professor in the nuclear engineer department here at UW-Madison. It is my pleasure today to start this panel to celebrate the Introduce a Goal to Engineering Day. So I'm very happy to see a full room here of high school students. This panel is also part of the Diversity Series of the NEDHO, the Nuclear Engineering Department Heads Organization. So it's also being streaming online to other engineering departments in the United States. And it could not have happened without Sam Vold, which I don't see here now. Oh, there. Say hi, Sam. Thank you for organizing today and all the tours at Expo. Thank you. She's our communication specialist in the department and has done all of this amazing work today. So thank you. I have the honor to moderate this panel today, and please welcome welcome our panelists. I'm going to start calling Amber Dotzler, the Nuclear Criticality Safety Engineering at Paschal Solution. Welcome Tracy Radel, the Vice President of Engineering at Shine Technologies. Kirsten Laurin-Kovitz, the Associate Lab Director at the Argonne National Lab. And Lisa Marshall, the Vice President, President-elected for the American Nuclear Society, and an Assistant Extension Professor in the Nuclear Engineering Department at North Carolina State University. Thank you all for joining us today. So, growing up in South America myself, I never imagined being an engineer. At the age of 20 is when I decided to change my major. I had never had friends or family members as engineers to draw inspiration from. It took me a lot of courage to change my major, accomplished with the help of a few great mentors that advised me through my path. Nuclear engineering, as many other engineering majors, still lacks diversity. Proper representation, it is one of the many barriers that we continually face. Our field wishes not to miss any more talented individuals, landmark innovations, and inspiring creativities that comes through diversity. That's one of the main reasons we are here today, to celebrate the Introduce a Goal to Engineering. I would like to start this panel by ask each of our panelists to share a little of your career journey and what inspired you to pursue a path in the nuclear engineering. Thank you. Any of you?
Okay, so I'll start. My journey in nuclear engineering actually started at an event very similar to this one. So in my junior year in high school, summer after my junior year, I had no idea what I wanted to do. I only knew that I didn't want to be an engineer and I didn't want to go to UW-Madison. But thankfully, my math teacher convinced me to go to an event similar to this at UW, where they introduced all different types of engineering. And after a 30-minute tour at the nuclear reactor, I decided I wanted to go to Madison for nuclear engineering and didn't look back. So after getting my bachelor's and master's in nuclear engineering here at UW, I went and worked at Sandia National Labs in Albuquerque, New Mexico, and did the launch safety work for the Mars Science Laboratory rover mission. So that was figuring out where the plutonium would go if the rocket exploded on launch. So thankfully, all the analysis I did for 4 years wasn't necessary in the end, and the rover made it to Mars, but it was a fun project. And then I went to work for Shine Technologies and spent the last decade or so designing, constructing, licensing a first of a kind nuclear facility in Janesville that once it's up and running will provide about half of the US demand for the medical isotope Moly-99. So doing nuclear medicine work, which has been great. So that's me.
So my path has been a little bit more winding, right? So I always knew I had to go to university. It was something that was drilled into us. It was part of the conversation time and time again growing up. I'm originally from Trinidad, and I grew up with my grandmother and uncles and aunts, whilst my parents were up in Canada, finishing off their studies, and then they sent it for me when I was a teenager. And it was always part of the conversation. You're going to college, you're going to college, you're going to college. But I had that choice, right? I was also told, and I agreed with it because I had that curiosity both for the social side of things and the science side of things. So I was looking for that major that combined both of them. And that's pretty hard to find these days still. I took a geography class and I fell in love with it because it dealt with the social and the technical components of energy, and I loved it. So I did my undergraduate degree in interdisciplinary studies, and then my husband and I moved from Canada to North Carolina, Raleigh, North Carolina, and I started a position at NC State's nuclear engineering program. They were looking for someone who would interface with students and general public around the technology, someone who could translate the technical into the conversational and engage individuals. And whilst I was there, I decided, well, I'm at a university, and I've got in the back of my head what my grandmother and my aunts and uncles and my parents have always said to me: always continue school. Education is key. So I enrolled in a master's program, and then now I'm finishing up a PhD program at NC State on the education side, engineering education, with a focus on nuclear. And that's how I've come to the field. In way of my specialities, geographic information systems. So if you're looking to figure out what components, what variables you need to take into consideration for a placement of a plant or a placement of interim storage, then you should come and talk with me or someone like me, right? So you're taking into consideration the geography, the morphology, etc. But you're also taking into consideration the community and their feedback, and how then do we engage with individuals from the beginning of the process of deciding where it is and what it is and where we would put it, right? Now, the Department of Energy just awarded 13 grants, and NC State is one of the locations. And we're looking at consent-based siting for interim storage. So there it is again. All the things that I've on that winding path are now coming back and situating quite nicely for that particular grant. And there are other things, but I'm sure those will come out either as the questions that are posed to us, or the questions when we get to the Q&A section that you have.
Well, those are hard stories to follow. I'm Dr. Kirsten Laurin-Kovitz. I'm at Argonne National Laboratory. I'm the daughter of a Lutheran pastor and an elementary school teacher, and I'm the oldest of 3 girls. And so engineering was not something that I was familiar with from my circumstances growing up. And in fact, I have to credit my physical science teacher in keeping me after class one day in high school. And everybody was like, oh, Kirsten's being kept after class. What's that all about? And he said, have you ever thought about engineering? And I'm like, I don't know what engineering is. And then I looked into it, and my family couldn't have been more excited that I was being encouraged to go into engineering. So I continued to study a lot of math and science in high school, and eventually went to University of Illinois, where I got a degree in general engineering, really in business systems and general engineering. And I really wasn't sure what I wanted to do with my engineering degree. I got married, decided to go back to graduate school and enrolled at Northwestern University in a master's robotics program. So I completed my master's robotics program, still kind of wondering what I wanted to do. And the chair of the Department of Mechanical Engineering at Northwestern was a nuclear engineer himself. And he had a part-time appointment to Argonne National Laboratory. You can see where this is going. And he encouraged me to do my PhD work, to stay and do PhD work in nuclear energy topics with a research project at Argonne National Laboratory. So great. So the door opened for me and I walked through it and I started my research project in perturbation methods for analyzing nuclear reactor analysis or nuclear reactor fuel, and finished my PhD at Northwestern and got a postdoc as well that's an after you could finish your PhD, you could stay at a university or at a research institution and do a short-term research project that continues on usually with the work that you've been doing for your PhD. Again, I didn't think I was going to stay. I just, was doing work that I was really enjoying and meeting people. Argonne National Laboratory is one of 17 U.S. Department of Energy national laboratories. It's a science laboratory, so it's multidisciplinary. It has lots of different science and engineering. It happens to be the place where Enrico Fermi set up a national laboratory after he did the first controlled nuclear chain reactions. So we're really well known for our nuclear energy programs there. And at the time when I was doing my PhD, nuclear energy was on the rise again. And but there was a change of the political winds, and they decided to cut some of the funding to the nuclear energy programs. Being at a place like Argonne, where there was lots of opportunity to do different types of research, I took my nuclear education, nuclear education, and I pivoted toward a national security topic. It's called non-proliferation. It's about making sure that civil nuclear energy programs are actually used for peaceful purposes and not diverted or misused for nefarious purposes like weapons. And so I spent the bulk of my career actually working to support civil nuclear energy in a way that ensured that it was used for peaceful purposes. And I got to do that while I got to travel the world and work with people in a lot of different countries to do that kind of work. And while I was at Argonne in my career, I happened to take on some leadership roles, first leading a group, then leading a department, then leading a division, and most recently leading the piece of the laboratory that's responsible for nuclear technologies and national security. I have really great people that I work with. About 550 people work in our directorate on advanced nuclear energy topics, non-proliferation topics, and then homeland security topics related to critical infrastructure, risk, and resilience. So I've been so lucky to have what I think is a very rich and full career, just kind of following where the path led me. Not quite straight, not knowing exactly what I wanted to do, but it's something that I'm really passionate about. And today, we have a real opportunity in nuclear energy to make an impact in the world. To Lisa's point, there aren't a whole lot of places where you can do something and have great societal benefit, do something super technical and great societal benefit, and nuclear energy is one of those places.
Hello, everyone. My name is Amber Dotzler. I am the youngest of the panelists here. I have been in the workforce for about 8 years. I graduated from UW-Madison in 2016. I'm a Wisconsin native. I grew up in Waukesha. I went to Waukesha West High School, which I think I see some students here. Very exciting. When I came to UW-Madison, I knew I wanted to do engineering. I was always strong in math and science. And when I applied to the university, I had selected chemical engineering. I didn't know much about any of the engineering majors. I didn't have much exposure when I was a high school student. I knew a little bit about engineering, took some general engineering courses, but really didn't know too much about each of the disciplines. And during my first year at UW-Madison, I got more exposure to the different engineering departments. And I started to hear about this nuclear thing, which I had certainly not known anything about. And I started to really gravitate toward my physics classes, and I got really excited about the coursework. And when I learned there was a nuclear reactor on campus, I was like, that's really cool. I want to do something that not very many people are doing. And that really motivated me to jump into that major, and I've loved it ever since. When I graduated, I was fortunate enough to take a job in Oak Ridge, Tennessee at Y-12 National Security Complex, which is one of our nuclear weapons complex facilities. They're often referred to as the Uranium Center of Excellence for our country, where they store a lot of uranium, they do uranium recycling and stockpile stewardship. So for 6 years, I was a nuclear criticality safety engineer there. And criticality safety is associated with making sure that uranium or plutonium materials that are fissile are stored, transported, handled, and processed safely to prevent a nuclear criticality accident. And a criticality is what happens inside a nuclear reactor that releases a lot of heat and energy and radiation, and is a great thing when it comes to generating nuclear electricity. But outside of a reactor, we never want that to happen. So that has been the bulk of my career. And in the last couple of years, I had an opportunity to come back home, so to speak, and support the SHINE facility in Janesville, which has been wonderful. Got to support their safety analysis program there. And in most recent years, I've transitioned to a new project in Southern Ohio where they are enriching uranium. They're producing something called HALEU, which is high assay, low enriched uranium, which will help support advanced reactors, small modular reactors, kind of these next generation nuclear projects. So my career has been really exciting. As short as it has been, I've gotten to support medical isotope production, our weapons stockpile stewardship, and now kind of sort of electrical generation in the fuel fabrication sense. So it's been really exciting.
Thank you. So we're going to move to questions. If anybody in the audience here, please have a question, please raise your hand. And we do have microphones that are going to be given to you. Online, we have the Q&A option as well. But we can start with some of the questions that was submitted in advance. I wanted to start with a simple question that was submitted by our high school students that I think anybody wants to know. What is your favorite part of your job?
My favorite part of the job is the people that I get to work with. So I find that the people that go into engineering are really passionate about solving problems with math and science, which is what it's all about. And they're really eager to help solve issues. And that is really done best in a group and in a team environment and with a diverse group of people. So diversity actually drives innovation within the industry because you want lots of people with different ideas that can challenge each other in a healthy way and come up with more and more ideas so that you can get to that best idea. And the times when I've just been super energized at work is when we have those really, really intense cooperative problem-solving discussions with each other and come to a great solution. So that's what I enjoy.
Anybody else want to share?
So one of the favorite aspects of my job is similar, working with really great people, diverse people, but also that I get to learn about so many different types of processes, systems, technologies that aren't necessarily nuclear, so to speak. In order to understand a process, to develop a safety analysis for it, you really have to understand how that process works. So I've gotten exposure to machining processes and chemical processes and all of these extraction and really complicated processes that you wouldn't necessarily think a nuclear engineer might be exposed to. And I've gotten to develop a greater understanding about a lot of different technical concepts. And every day I'm learning, which I think is one of the most exciting parts about my job. That every day is new, every day is exciting. I'm not doing the same thing day in and day out. And I really enjoy that about my job.
Thank you. You want to share? Okay. Please.
One of the things that I like about my job is the opportunity to bring together the technical and non-technical audiences for nuclear energy. So in the Department of Energy, we work very closely, not just with engineers and scientists, but also with people who are setting policy related to nuclear energy or other science policy topics. And in the role I'm in now, I have the opportunity to really interface with people in the government and people in non-governmental organizations and international organizations to be able to influence and to share my knowledge about nuclear energy in a way that the public and others can make effective and best practices and policies for the future.
I like working with students like you. That's the most important thing to me. I was hired into the nuclear engineering department at NC State to kind of spearhead a development of a outreach program, and that is wide, right? And I focused, at least at the very beginning, and it's still a core component of what I do, is interacting with students your age and younger and a bit older as well, from community colleges and those that are transitioning from the beginning of one career to another. And the reason why I like that is that you keep me young. All of you keep me young with the types of questions that you ask, and then also to help you navigate, because I think there's a whole lot more choices than when we were going to school. And that can be paralyzing at times. And you just want someone to ask a set of questions that then you can go back and think through yourself. I'm not there to answer those particular questions, but I'm there as that support mechanism and to guide you in a direction so you can make an informed decision. All decisions in the way of your career are important and they're valid. And I'm just trying to help you to navigate the educational system, which can be daunting at times, right? So I have individuals, since I've been in the industry for 20 plus years, that they're sending some of their kids to our program, right? Some of the postdocs, et cetera, that have our graduate students and postdocs, they've had toddlers, and those toddlers are now teenagers, and they're sending them back to our high school program. And how cool is that for me to then touch so many different generations? I have to go back to it. You guys keep me young with the types of questions that you ask, and just to see you flourish. So I can think of one student right now. There are a few others, but this one in particular, and I think she'll be able to identify based on some of the things I'm saying. She went to an academy school and started taking dual enrollment courses, right? And she had an idea that nuclear may be what she was interested in, and to be able to mentor her in the sense, okay, you need to do this, this, and this early on, even before you come onto the campus full time. And then when she got there, to get her involved in undergraduate research, and then to give her that gentle push, it's like, you need to go to a few conferences, right? It's like, I don't know how I'm going to pay for this. Or it's like, don't worry about that component. We got you, right? But just give her that additional push, because she's doing the undergraduate research, that she should be telling others about the research work that she's doing. Fast forward a few years, and now she's considering graduate school, and she's got a number of offers for graduate schools, and helping her to navigate that as well, that it is the right topic area with that right faculty member, right? And that once that relationship is matched, you're good to go, right? This individual will be in your life literally forever, because I think of some of those influential faculty members. They saw something in me before I noticed it. And I kept on always wondering, would you leave me alone, right? Why are they pushing me to do such and such? I don't like speaking in public, right? And look at me now, right? I'm talking in public. And she also brought that to my attention. And every time she sees me, she brings that to my attention, right? But it's just nice to see a young person move from, I think this is what I'm interested in, to, yeah, but there's still a whole bunch of questions that I need answered. And they know at least one person who will, connect them with another set of individuals that can answer those questions and be there as a safety net, right? As we're walking through. There are another individual that I know, he just did a seminar yesterday at our university, and he was an undergrad in our program, right? We're both on the policy side. And then how then do you speak the technical to the policy individuals? So I can't say enough. You guys keep me young. And for that reason, that is always going to be the best part of my job.
Thank you. We have a question here, then one in the back, and then there.
Hi, I'm speaking on behalf of Sydney Tomte and Stella Cognac from Baraboo High School. They asked me a question. I went to grad school as well, but they asked the question, how do you pay for school? My family doesn't have a lot of money. And so can you walk me through that? And also how do you pay for school once you get there? Like, how do you pay for life? How do you do that?
Yeah.
Yeah, so I was maybe in a similar situation where my parents couldn't afford to help me with college at all going into it. I worked really hard in high school and did get some scholarships that helped. But I think engineering is a great field for that, in that any internships I did were paid at a pretty good amount. Whereas if you go into humanities or something, it's generally an unpaid internship. There's lots of scholarships, especially to encourage diversity within the field, right? Like I said, innovation is really driven by diversity, and companies recognize that, and they've put a lot of scholarships out there to help improve diversity within the organization. The department itself gave scholarships. Some I didn't even apply for. I'm not sure exactly how they got selected, but they said, hey, you've gotten this scholarship, and there's if you want to go to grad school, you can generally get paid to do that. It can be funded through the university. And so I had a fellowship that paid for my master's. Here, I actually studied abroad in Budapest, Hungary while I was here, and got that paid for with a scholarship that was specifically targeted towards studying abroad within engineering. So there's a lot of financial help out there. I did 5 years at UW-Madison and came out with 0 student loans. So, with my parents not being able to help fund my education. So don't let that be a barrier. And actually, I would encourage that engineering is a great way to go.
Thank you. If you want to add, okay.
I just want to add one other thing. At the beginning, once you've put in the application at a particular university, you'll be interacting with a number of professors and outreach individuals, academic advisors, etc. Find the one or the ones that are representing particular engineering majors that you're interested in, and chat with them. So it's undergraduate research, it's work study programs, it's incoming scholarships, because a number of the organizations, such as the American Nuclear Society, have scholarships for incoming freshmen, right? And then they have the sophomores, juniors, and graduate students. There are national big scholarships, and then there are smaller ones. But when you add them all together, there's a nice sweet spot for you to move forward. And a number of universities now have something similar to engineering your experiences at the undergraduate level, so that you can go to conferences, so that you can do study abroad programs, so that you can go on field trips. And then by the time you get to the graduate level, it's slightly different. You have to make a match for what you're interested in with the faculty member that's their research area. And they go after the money instead. And then they're looking for individuals to hire as teaching assistants as well as research assistants. And it's a full ride.
And Lisa makes a great point on undergraduate research. So if you're kind of have a financial need, you can get work study funds, and a lot of kids will earn those work study funds by working in a cafeteria or something kind of generic. But you can actually use those work study funds to fund working on a research project. So as a freshman, I got to work on a research project and get my work study funding through that. And I'd definitely encourage you to reach out to faculty as soon as you enter the university. And a freshman is not too early to help out on a project. Yes, you get like the less less flashy jobs, but you're learning. And I was on a fusion research job as a freshman and helping contribute there. So that's another way to do it.
Yeah, that's right. The students are paying the undergrad research since freshman, depends of the lab, and all the grad students in our department are fully paid tuition, health insurance, like a large part, and the stipend. We have one question in the back.
Hi, I'm Zamaila and I'm from Bell Phillips Memorial High School, and I'm so curious about this. What's the obstacles you face pursuing engineering as a woman and how you overcome it?
So the balance between male and female in engineering still tilts more so to male, right? So you tend to be one of a smaller grouping, and that can be intimidating. My grandmother, who I think we figured she probably finished elementary school, had great pride, and she instilled it in us. Head up, shoulders back, you belong, and you just do it, right? And I have translated that to being bold, right? There are going to be individuals in your cohort that will welcome you, and then others may kind of look and say, what are you doing here, right? You got to learn how to ignore the, what are you doing here? And hang out with the individuals that affirm you being in that space. And what you'll find is that the faculty are there to support you, right? So we are some of the loneliest people during office hours. No one comes to visit unless there's a problem. But that's the right time to come to visit and just to sit with us. You don't have to have a particular question. It could be that, well, you have office hours and I just, I don't have any particular questions, but can I find out a little bit more about your research? I've been reading your website and I see, and some of it is going over my head. And that's all you have to say, really, to a faculty member, that you want them to talk about their research, and they'll go on forever, right? But you're building that rapport with someone, and the more we know about you, the better, right? The questions that you have, the securities or insecurities, the hopes and dreams, what you think you want, direction you want to lead, to go in. The more we know, then we can think about experiences that build you up, so to speak. And eventually, those numbers are going to even out.
I do want to put in that I've actually, it was something that was a concern to me going into engineering, but I've actually found more kind of good than bad in that there's a ton of support for increasing diversity within engineering. And I think that support that I've received over my time at the university as well as my career has far outweighed any of the barriers that I've come up against. I think the two areas that I've seen kind of impacts, and I don't know necessarily whether it's because I'm a woman or, because I was younger at the time or, earlier in my career, but, definitely some like assumption that I don't, know as much as others potentially. Or, it comes out as more like surprise when I do know what I'm talking about or, can speak intelligently on a topic. That was one of the things that prompted me to get my PE, my professional engineer license with the state of Wisconsin. Having a PE kind of helps say, hey, I kind of do know what I'm doing in this field. And that was one of the reasons that I got it. The other thing that I've run into is it's pretty rare, but like the personality of kind of trying to be overly aggressive to win an argument or a discussion or, as you're talking through ideas, can sometimes come out more towards females, but each time I've just recognized it for kind of what I think it is, which is they're kind of intimidated or fear of kind of your ideas in the space and just kind of, step away and, have your boundaries and address it in a really calm way and their behavior, people see that and can judge that for themselves and just kind of maintain your integrity in those moments. So that's been my experience.
So I just wanted to reiterate something that Lisa said about finding the people that you hang with who will support you. Early in my career, I had very few women that were working in the nuclear engineering division at Argonne National Laboratory, but I made friends with all the people in the chemical engineering. There were a lot more women there, so build a support group that will help get you through, and realize that you may be the only woman in the room. That's unusual for you. It may be unusual for the balance as well. And so I found that more times than not, the kinds of things, the surprise that people show or the assumptions that they make are just because that's what they're most used to. And so I like to say, give a little grace, that it's not always intended to be such a, aggressive thing or you don't belong here type of thing. It's just, they literally are not as experienced in working with people from a more diverse set of backgrounds. And so give a little grace, maybe you'll get a little grace and build a network.
Thank you. We have a question on this side here.
Hello.
Are you want to stand up?
Hello, my name is Juliana and I attend Milwaukee Excellence. My question was engineering your first choice or did you have something else in mind?
So I didn't start in the engineering arena, right? I started in interdisciplinary studies, which was still very a less known discipline, so to speak. And then I gravitated to geographic information systems under the umbrella of geography. And then into, as my work within engineering, and thought, well, I'm in engineering, I need to be equipped appropriately. So I did engineering education because I'm in that university setting and working with students in the first year engineering program, and then the study abroad program where we're doing some co-curricular work, right, in support of. And then I'll start soon to advise graduate students looking at qualitative and quantitative research methods in the engineering field. So mine's a little bit more winding than the other individuals on the panel, but I found my home in engineering, right? Because engineering too, it's about that societal good, right? And the technical know-how, the innovation to make individual lives and then communities, societies, nationally, internationally, make an impact is very rewarding, right? So that's why I gravitated, and it all roads led to engineering, and you can't get me out of it if you try.
So I said in my opening remarks that my father was a Lutheran pastor and my mother was an elementary school teacher, so I didn't know much about engineering. I did consider both of their careers as potential career paths for me before kind of got my eyes open to engineering. And what I would encourage people to do, and I think it's true. A lot of us, we know what our parents do, right? We see that every day and we either run from it or we run toward it, right? And so I would just encourage you to find others in engineering, adults, mentors that you can learn from and really discover if that's a good fit for you, right? There are going to be influences in your life that are from your background that maybe make it seem like the easy path or the path you want. But once we had this idea that maybe I could be an engineer, my uncles and all kinds of people started coming out of the woodwork to encourage me. And so I think just find some people to encourage you.
I think what Kirsten said there too is super important of trying it out before you decide it's right for you. Like I said, I knew I didn't want to be an engineer. It sounded so boring. Like, I kept being told, and all those career surveys kept saying engineering. I'm like, well, I don't really know what they do, but it sounds boring. And then, I decided I wanted to be a wildlife biologist. And there's actually a wildlife biology camp up in the UP. So that summer that I went to the engineering camp and I also went to a wildlife biology camp, realized that was incredibly boring and I never wanted to do that. So whatever it is you think you wanted to do, just make sure that you go try it out or job shadow or, take part in one of these many camps that you can go to and just experience it, so that you can kind of have a better sense as you go in. Not that you need to know what you're going into when you go to college, but especially if you want to be efficient with your funds, it helps to know what you want to do when you get there. So.
I just want to add to that. You've spent the day here and you've met a number of individuals. So now they are your resources, right? You can pick up the phone and say, I was at this particular event and I want to explore it more. And I don't think that anyone here will deny assisting you in finding out a little bit more about engineering and finding opportunities through maybe summer camp or shadowing or just sitting down and having, I don't know, I would say tea, but you may not want to have tea, but just getting together and chatting a little bit more about it, right? I think that is the entry point into a profession like this. And all of us now, right? Including us up here, right? That you can call upon at any time.
Thank you. We have another question here.
I'm Brooklyn Watkins from Beloit Memorial. And my question is, what would your advice be to somebody who's interested in the field of engineering but does not know what type of engineering?
So the summer camp that I went to is a great option. It's put on by the Society of Women Engineers, and you try out all different types through the course of a 1 week stay in the dorms at UW, and it's a great experience. I'm sure there's others. I think Michigan Tech has a similar week-long or multi-day one where you get to try all those different types and really see what they're about. So I recommend that.
To add on to that, I did not do any summer camps or have much exposure before I came to Wisconsin, but I knew I wanted to do engineering. I didn't know what kind. So one of the resources when I got to UW was that I lived in the Women in Science and Engineering learning community. And that was invaluable because I was with a bunch of other girls who were going through the same thing that I was, where we have these similar interests and aptitudes, but we don't actually know where we're going to land. And then the other thing that I would say is, while it's important to choose a major, again, you're only an undergrad for 4, maybe 5 years, your major doesn't equal your career. So while you might be, choosing between nuclear or material science, your career can still go in the same direction no matter what. Even if you're a mechanical engineer, you can work in the nuclear industry. If you're a chemical engineer, you can work in the nuclear industry. If you're a biomedical engineer, you can work in the nuclear industry. And while I was at UW, I actually worked in the engineering advising office, and I helped students register for courses during my junior and senior years as a SOAR advisor. And that was one of the, I think, most important things we told new students coming to Madison was your major doesn't equal your career. You can still do whatever you want. It's just a tool to help you get started.
I just wanted to add one other piece to that. Their first year is a general engineering year, right? So you typically will have some introduction to engineering sets of courses, and that serves as an exploration into the fields that are offered by that university, right? So it's an opportunity at that point to go a little deeper in maybe I don't particularly like chemistry, so that may take some majors off of the table. And I was like, oh, that seems interesting over there, that physics stuff. And gravitate to it, maybe do a project or two on a particular major for that particular course. And then it's 2 semesters, right? And there's a second course like that. So you can go a little deeper and a better understanding before we ask you to pick a major. And then picking a major does not mean that you've got to stick with that particular major till the very end, right? Some students, as they get further along, go, and then they'll make a switch. We prefer that you don't do that, that the first year is really that exploration, but it happens. Or you narrow it down to 2 or 3. Well, maybe there's a minor in one of those, right? So maybe you're doing nuclear with a minor in materials, right? And I've known of students who've done a major in nuclear and a minor in creative writing, right? So that kind of pulls in all of their particular interests. And that then helps you to figure out, what do I want my undergraduate to be in? And then you have students, if they finish a nuclear or they finish another engineering degree, and for their graduate work, they want to do MBA, right? Or they want to switch majors. Maybe they started in mechanical and they move to nuclear, or vice versa. So there is some portability of the majors that you choose. Just get to know your faculty members and get to know your academic advisors, because then they can help you talk it through and make some decisions.
Just one quick, her mention of MBA reminded me that if you're not convinced that engineering is for you, if you have the skill and the interest in pursuing engineering, it can take you to a lot of different places. So an MBA, which a business degree, a law degree, a medical degree, engineering is a solid foundation for all of those. And you'll be unique in that space too. The engineers who go into law have different opportunities than other lawyers do. So things like that. If you aren't convinced that engineering is for you, I'm just telling you, it's a great foundation and you can build on it.
Thank you. That's a great point. Here, question.
Hi, my name's Abhinav. I'm a sophomore at Middleton High School, and my question's more nuclear engineering based. How long do you guys think it would take for nuclear fusion to be commercialized and used in everyday purposes? And what factors would increase or decrease that time frame?
There's going to be a wide variety of answers you get to that question, depending on who you ask. Shine Technologies was founded with the ultimate goal of getting to fusion energy, but realizing that fusion energy is really, really hard. And so what Shine's been focused on is stepwise developing the technology and materials and really physics that we need to get there with near-term applications. So some of the technology we need to make fusion happen doesn't exist right now. And so, trying to make sure that we use fusion for good purposes while we're developing that technology. And so Shine's applied it to do quality control on turbine blades, QA assessments with neutrons. Medical isotope production is what I worked a decade on. So we couple the fusion source with a liquid fission subcritical assembly to make Moly 99. And then the project that I just started working on at Shine, which is our phase 3 effort, is using it to transmute nuclear waste. So the long-lived isotopes within nuclear waste, hit them with high energy neutrons, and you can transmute them to short-lived isotopes. So we're working to design a nuclear waste recycling facility that can separate out those isotopes, take the valuable materials, and reduce the kind of high-level waste needing deep geologic disposal by 95%. So we can use fusion for really great near-term applications and develop the technology needed to get to fusion energy eventually. If you ask me personally how long it's going to be, I think it is, that 30 to 40 year time frame. I know some companies are working, on the 5 to 10 year time frame, or but it's really hard. Fusion's hard. So.
I just want to add that after this panel, you're going to have an expo outside, and there are some fusion startup companies that you can ask them about this. We have 2 more questions, one in the back and then in the front. Please go.
Hi, my name is Ajane Sherman, and I am a proud student of Milwaukee Excellence. And my question for you today is, have you ever felt self-conscious about your job?
Yes. I think, well, I don't know how many people in the room have heard of this term that people put for that, being self-conscious about your job or your capabilities in your job, being called imposter syndrome, right? And literally every time I'm in a group of esteemed other people, I still have that, but that doesn't mean I don't belong here, right? It's something that I recognize is a concern sometimes I have, but I have to reflect on the solid career that I've had and the ways I've interacted and had. And so I think people, I think a lot more people than you think have imposter syndrome, put it that way. You think, oh, look at this person. They have this great job and they have this great degree and they've been in this leadership role. They're just worried about doing it right every time too, just like everybody else. So don't let that stop you. I don't know, other people have some.
Oh, every day when I wake up, right? Right. It depends on the events or the activities of the day. But there's always a portion there that follows me. And I try to quiet it in the sense of I belong. And I wouldn't have gotten to this point if my boss didn't realize it and hire me in the first place, and that I can learn, and I can learn anything at any time, right? So what I don't know, there are wonderful resources that are at one's fingertips, a whole lot more than in the past. And then I'm not afraid to ask. So it's like, what were you talking about? This is my interpretation of what you're saying. Did I get it right? What am I missing? Right? And because engineers work in a team, and it's a mixed team in many instances, everybody's bringing their strengths to the table. So there's a lot of questions that are being asked constantly. And that's just to make sure that the project that we're working on goes forward in the best form possible. So a little of that imposter syndrome, just to have you focus in and go, no, I can do this. I just got to ask some questions. I got to do my research. It's a team effort. I think it's a good thing, although it doesn't really feel good at the moment, but I agree. We feel it too, right? And it's something that you learn to put in its place. That no, I'm supposed to be here. I've done the work necessary, and I'll continue to do the work necessary to contribute to the project.
Okay, we have one more question here. And I want to add, having your support system, mentors during your career and mentors in your personal life helps a lot, because as much as we say, I belong, sometimes we're going to doubt that. And having somebody else that believes in you helps a lot. So please.
Hello, my name is Grim Bennett. I'm a student of Madison East High School. I would just like to know, what is the absolute #1 most important piece of advice for aspiring engineers?
Great question. This is actually the final remarks of our panel. We are just about the hour, so I'm going to extend the question and ask everyone in the panel to answer, giving the most important piece of advice that we can give to this amazing audience today.
Ask a lot of questions. Be inquisitive. Find your community, right? And that community, it's going to help you move forward. And lastly, for me anyhow, be bold. So if this is something that you want to do, then do it, right? And in way of being bold, that means then you're finding the right individuals to ask the right questions of, that then they can guide you. There's no reason to reinvent the wheel, right? What we're doing is building upon what has been built before. And that's why we do events like this. That's why you've got different individuals at universities and at your high schools, your support mechanism, your teachers, your counselors, etc. We're there to help, right? And for you to go further than we have, quicker, right? By having that community, so that you feel comfortable asking those sets of questions, and that you can, it's always nice to know, right? That think about a toddler, right? That they're hanging around their parents, but they really want to go and play with something that's over on the other side of the room. And they'll take a few steps and they'll look back, and they'll take a few more steps, right? So they're tethered, right? They know that that other person behind will capture them. Will catch them, right? So what you want to do is to find that mechanism, that community, so that you know you're solidly tethered, and then you can explore everything else that you're interested in.
My advice would be, don't be afraid to make mistakes, and don't be afraid to fail and fall down, because studying engineering and working as an engineer, you're going to make mistakes. The cool thing about engineering is that we work on projects that are first of its kind. So nobody has the right answer and nobody knows what the path looks like. So you're going to make mistakes and you're going to fail, and it's going to be uncomfortable, but get used to being uncomfortable and figure out what it takes to pull yourself up and keep going. That's how we learn, that's how we grow, and know that that's just part of engineering.
So all great advice so far. I would say be authentically you in the job. I think one of the things that engineering needs is people who think differently than the person across the table from them. And sometimes it can be tempting to do engineering the way everybody else is doing it, kind of in the same mold. And I do think that we have more to offer than just the same methodologies, the same approaches. If you have a fresh idea, that you should put that forward, and you shouldn't feel like you have to conform to some image of what an engineer is. You can do engineering your way. And the other thing I was going to say was be open to other people's opinions. So that it goes both ways. You should bring yourself. You should let everybody else bring themselves, so that you can work as a team to come up with the best possible solutions. The best thing about engineering is if you love solving problems, you get to do that every day. Like the thought processes you learn in engineering are good for not just the job, but for life, and how you deal with everyday challenges as well as technical challenges. So be authentic and be open to other people in their approaches to things.
Yeah, I second the point Amber made and you know, that you learn a lot more through your failures. So when you try something and it doesn't succeed, than you do when everything goes right. So you know, my biggest lessons learned are things that didn't go well, and taking the time to reflect on why that was, and what I would do differently next time, and where in the process I would have made that choice based on, you know, what I saw. You know, not beating myself up too much, because you make the best decision that you have in that moment, right? But learning from each of those experiences. I think for me in my career, one of the biggest things that I've really focused on is trying to make sure that I'm really contributing to trying to help everyone around me be successful in what they're trying to do. I think, you know, in school with testing and kind of how school is structured, sometimes it pushes us to try and get the best score. And like, if you're kind of better than everyone else, that's looked at as a good thing, and you're competing against everyone around you, right? Or it feels like that sometimes. And engineering is really kind of the opposite of like, we don't really succeed unless we're all going to succeed together in it. And so you really got to kind of shift your mentality going into a career in engineering, or, you know, even at the university, of like, engineering is a team sport. It's a team thing. And in kind of focusing on helping everyone in the whole team be successful, I've found a lot of success in that, of like, you know, I can, that's what kind of led me into project leadership and executive leadership eventually, of like, how can I best help the team succeed? And focusing on that, I love, you know, what I do every day, because that's what I focus on. So.
Thank you so much. I'm going to invite everyone to go outside to the expo that we have a few companies, lab, and students organization. But let's thank you all panelists one more time.